Okay, type 3 is solving by factoring into binomials. So once again, we're in the quadratic form where we have a squared theta, or a squared plus b squared plus c. So in this situation, we have an a term, which is the secant squared theta. We have a b term, which is the 9 secant theta, and we have a c term, which is the minus 14. So we want to set this equal to 0. Before we do that, I want to recognize that we are going to have answers that are in degrees. And then we need to set equal to 0 and factor. So if I set this equal to 0, I'm going to have secant squared theta minus 9 secant theta plus 14 is equal to 0. So sometimes when we have those trig ratios in there, or we have those trig functions in there, the secant in there, it's hard to see how to factor this. So one option that you have is that you can say let a be equal to secant theta. So we can rewrite this as a squared minus 9a plus 14 is equal to 0. Then it's easier for us to see that this will factor to a minus 7, a minus 2. Now we can go ahead and substitute that back in, and we can see that a is really secant theta, so I'm going to have secant theta minus 7, secant theta minus 2 equal to 0. Now we're just going to have two equations that we need to solve. Okay, I'm actually going to move this over so I have a little more room. So my two equations that I'll have to solve. My first equation is going to be when is secant of theta minus 7 equal to 0? And my second equation is going to be when is secant theta minus 2 equal to 0? So let's start on the left and solve that equation. So I get here, when I solve this equation, I'm going to get when is secant theta equal to 7. So this is not in my exact value chart, so I need to use my calculator. I need to make sure that I'm in degrees, because my answer needs to be in degrees. I don't have a secant button on my calculator to get that reference angle, so I'm going to go ahead and think of this in terms of cosine. So I can write this as cosine theta equals 1 over 7. So in my calculator, I'm going to plug in cosine inverse 1 over 7 is going to give me theta. If I do that, I'm going to go ahead, make sure I'm in degrees. 1 divided by 7 gives me 81.79. So theta is equal to 81.79. So in this instance, my reference angle is equal to 81.79 degrees. I need to think to myself, when is cosine or secant positive? So when is cosine secant positive? If I look over at my chart, I can see that cosine and secant are positive in quadrant 1 and quadrant 4. So I'm going to have solutions in quadrant 1 and quadrant 4. So let me just kind of fit this in over here. My solutions. My quadrant 1 solution is going to be 81.79. My quadrant 4 solution is going to be 360 minus 81.79. So I get 278.21 degrees. So I have two of my solutions here, my first quadrant and my fourth quadrant. So now we need to go and solve the other equation. When is secant theta minus 2 equal to 0? That should say 0. So if I go and solve this, I get secant theta is equal to 2. This is nice because this is an exact value, so it makes it go quicker. So if I look over here, when is secant equal to 2? Secant is equal to 2 at pi over 3. So that means I have a reference angle of 60 degrees. I need to know when is secant cosine positive. When is, let's just say secant because we're not really. When is secant positive? We're going to be in the same quadrants again. That's in quadrant 1 and quadrant 4. So I can now come up with my solutions. My quadrant 1 solution will be 60 degrees, and my quadrant 4 solution is going to be 360 minus 60, or 300 degrees. So we have two more solutions here for our equation. All right. Let's do one more example like that. Example 6. So for example 6, we're still going to solve by factoring. I'm going to go ahead and I'm going to rewrite this and set it equal to 0 and factor. So I'm going to set equal to 0 and factor. Sorry. I'm going to get 6 cosine squared x minus cosine x minus 1 equals to 0. Once again, I can do the substitution if it looks confusing for me to factor. So I can say let a equal cosine x. If I do that, I'm going to have 6a minus a minus 1 equals 0. I can go ahead and factor this. This gives me 3a plus 1 and 2a minus 1. When I factor, oh, this needs a square. 6a squared minus a minus 1 will factor to 3a plus 1 times 2a minus 1. So once again, we'll have two equations. We're going to have when is 3a plus 1 equal to 0 and when is 2a minus 1 equal to 0. So we'll go ahead and split this into 2. My solutions need to be in radians. So that's important to remember. So we'll start with my first equation. Let's rewrite this with cosine in it. So I can now substitute this back in and say 3 cosine x plus 1 and 2 cosine x minus 1 equals to 0. So we're going to have our two equations. This is going to give me 3 cosine x plus 1 equal to 0. My other equation is going to be 2 cosine x minus 1 equal to 0. And I can go ahead and solve. I'm going to get cosine x by itself, so I get when is cosine x equal to a negative 1/3. In this case, this is not an exact value. We need to use our calculator, and we need to make sure we're in radians. So I'm going to plug into my calculator cosine inverse of 1/3 equals x. I want to use the positive value here. Because we're looking for that reference angle in the first quadrant. So if I do that, if I plug that into my calculator, I want to make sure I'm in radians. So my mode right now is in degrees. I switch to radians. I'm using cosine inverse. 1 divided by 3 gives me 1.23. So x is equal to 1.23. So I now have my reference angle is equal to 1.23. I need to ask myself, when is cosine negative? I can look over at the chart and see that cosine is negative in quadrant 2 and in quadrant 3. So that's where my solutions lie, in quadrant 2 and quadrant 3. So now I can come up with my solutions. My solutions will be my quadrant 2 will be pi minus 1.23, which is 1.91, and my quadrant 3 will be pi plus 1.23, which gives me 4.87. So those are my two solutions for the first equation. Now we need to find our two solutions, or our solutions for the second equation. So we have, I'm going to rewrite this, I get cosine x equals 1/2. This is an exact value, so we can use the chart. If I go over to the chart, I can see that cosine is equal to 1/2 at pi over 3. So my reference angle is equal to pi over 3. I need to figure out which quadrant is cosine positive. So I can see cosine is positive in quadrant 1 and quadrant 4. So I'm going to say cosine is positive in quadrant 1, quadrant 4. That means I'm going to have two solutions, quadrant 1 and quadrant 4. So I can come up with my solutions now. My quadrant 1 solution will just be pi over 3, my first quadrant angle. And my quadrant 4 solution will be 2 pi minus pi over 3, which is really 6 pi over 3 minus pi over 3. And so I'm going to get an answer of 5 pi over 3. So I have my two other solutions here.